All right, welcome to Weather Lab 13. We're working on part 2, starting with question number 7. So question 7 asks you to look at the table down below in 13.1, so table 13.1 at the bottom of this page. And it asks you to look at the list of hourly pressures and winds, and specifically to look at these pressures and winds. All of them are for the town of Sumter, which in the map is right here. And on this map, they're showing you the location of the hurricane as it was flowing through. So this is Hugo flowing past Sumter. Now notice Hugo never actually hits Sumter with the eye. So Sumter is only going to get hit with rain bands. So it's going to be rotating winds from around the eye of the storm. So not the eye wall, these are the rain bands on the outside. So this will be tropical storm-like conditions. So to add to those facts, they're asking you to specifically look at the wind direction, so keyword wind direction, at the Sumter that occurs between 12:50 and 2:50 a.m. on the map. So remembering that this is a.m., so when I look down at my table, Sumter is done in military time, and these are the weather station for Sumter. So I can look at 12:50 as being a 00. So looking at the date, that means that this to 2:50, so this and this are where we want to look. And we're going to look at the change in wind direction for this. Now, the wind direction box that's here is written based on 180 degrees. So, or not 180, sorry, 360 degrees. And we practiced this in the last lab. This is where I give you the compass of 360, and you know that you have your cut of this being 0 degrees, right, or 360 degrees, depending on what you want to pick, and this is your 180 degrees here, so that you're looking at it appropriately. Which means that for my first station time date of wind direction is at 30 degrees, so 30 degrees is going to be kind of here, and this translates for wind directionality as well. So this is north, this is south, we have east and west over here, so west on this side, and we know that the 30-degree mark, which I probably should have put up my little middle point, I apologize, for the middle would be like here. This would be my 30 degrees. My next station is at 50, that's more like this, and then my final one is at 160, so it's like this. So for the first station point, my wind direction is going to be northeast, right, and more north than east. My second direction point will also be kind of to the northeast, but my third one becomes southeast. Now once again, the storm is rotating, and the location of Sumter is in the rain bands. So why might the wind direction, and look at the approach, so it gets really close right here at 2 o'clock. Is that 2 o'clock on there? It's hard for me to read it because it's zoomed out in a funky, fuzzy picture. But I believe it says 9:22, so somewhere in here to here is when the storm kind of hits, between the 1-2 o'clock range right here, where I put my black line is the date time of when the storm hits, which means before the storm, the wind direction seems to be to the northeast, and then when the storm hits, it's going to come from the southeast. And so there you go, answering 7. Why the funky wind direction? Well, it's getting hit with the rain bands of Hurricane Hugo, and the storm itself hits at 2 o'clock, or hits the area of Sumter around 2 o'clock, and so the wind direction picks up and rotates round, and the direction of the rain bands that are hitting the community are to the southeast. All right, so let's look at the next set of questions. All right, so looking at question 8, we're now looking at the towns along the coast of South Carolina that are going to be getting hit with the storm surge from Hurricane Hugo, and we're going to be marking different things on the image, so on image 13.6 here. Over on this table at 13.2, this table, this is the storm surge height. So all these is the storm surge heights of these different towns and communities that are on this map to the side. So question 8 asks you to mark the areas of the highest storm surge in figure 13.6. How did the path of the storm surge influence the storm surge pattern? So first things first, you need to identify the tallest storm surges, and some of them are right here at Bulls Bay. Let's see who else has some tall ones here at Bull Island, and here at the Island Palm, here at Sullivan Island. Anybody else really, really big? Oh, above, sorry. I mean, this one that's 13.9, that's still pretty low. There's a big gap between 16 and 13, so there's still like 2 feet of difference. So now we're going to mark these locations on our map. So this is one of them, so this part of the coastline here. And then they said Bulls Bay, that's here, so this is the bay along here. And Bull Island, and where else? Island Palm. Where is Island Palm? Is that right behind? Right below Island Palms. And then Sullivan. All right, so this whole part of the coastline here, this is where the surge was, right? So you've marked the area of the surge. How did the path of the storm influence the storms? Sorry, I picked up on a little coughing fit there. Apologize. So, continuing, I have my little highlighted areas of the storm surge. So let me first say that this location here obviously is where the main part of the storm hit. So this is where the first rain bands come to shore. And while the hurricane hits this entire region, because it is this wide, this area is the area that gets hit with the eye wall. So first things first is just to note that this is the location of the main part of the storm. This is the area that gets hit with the eye wall of the storm, so the fastest wind speeds. From there, the shape of bays do matter. So looking at question 9, how might the configuration of coast influence storm surge heights? Well, let's look up here where there's Myrtle Beach was another pretty high storm surge. On the other hand, let's look at some other places that were clocked, like North Island, which is on the inland of an inlet, and that one only had an 8.2, and Rockville, which is on the inland of the inlet, and that had a 5.7. So obviously these inland inlets are protected by the natural build of the land, so the shape of the land, to help it not get those same storm surges. On the other hand, Bulls Bay, which is a bay like a big old bowl, is an open bowl, so I can splash that water right into that bowl-like shape and have it radiate out. So everybody around the Bulls Bay region had really extreme wave heights, and it was exaggerated by the fact that it had that bay shape, that bowl-like shape. So just using common sense and just talking about something along those lines where, coastal shape does matter for the storm surge height because it can exaggerate the wave height in the region. Question 10, how could the timing of the hurricane's landfall on a particular day influence the storm surge height? All right, so this goes back into class notes. We talked about how we have tidal surges and we have storm surges. If the storm surge happens to also coincide with the tidal high, so high tide time, you will have an exaggerated tidal storm surge, a really tall storm surge that's even taller because it also has the high tide on its side. So it well exceeds your high tide marks and goes on extremes. So some sentence talking about that, but this is a good reminder of content about storm surge and tidal surges that we talked about in class. All right, so looking at question 11, just quickly noting in the general circulation, continental scale pressure and wind patterns do influence how the storm will travel. And so if I take a look at maps on both the surface and aloft, I can begin to see how the storm might bend or turn or move around things. And so for question 11, it says gradient winds flow, draw winds around the high and low pressures centers for each day. How did the circulation around these pressures and centers influence Hugo's path? So for this one, and you're going to do all 4 maps on the pages, so on here, but I'm just going to help you do the first one. So for low pressure, keep in mind that it's flowing in towards the low pressure and that it's moving in a counterclockwise motion. So I'm going to draw in some arrows to kind of get the feel for around the counter the clock, right? And you should get in closer. It's my big fat stylist is hard to write. The high pressures are going to flow away, and they're going to flow away clockwise because it's high pressure, so they're going to be rotating around like this, right? And my high pressure, and I'll do the high pressure out here, flowing away, right? And so you're going to complete this for this map, and this map. So you do the highs and lows and complete your little arrows. And then a quick sentence just talking about how it kind of moved towards the low pressure and moved away or around the high pressures, right? Some sentence that says that. So this will be all for the part 2 of this lab, and I'm going to start working on a part 3 to answer the last set of questions.